Hi everybody, welcome to Tutor to You, topic recap, focusing on cognitive approach, digging deeper into the memory section, and this is part of your Applied Psychology Study Live with Tutor to You. Let's start off with seeing what you know already. So on the screen is a 60-second challenge. The clock will count down, so keep your eye on the time. But what we'd like you to do is to have a look at everything that's on the left, A to F, and try and match it with the correct item on the right, numbered 1 to 6. You can write these down on your notes if you like, or you could even write them out as a correct table so that you've got it for future reference. So read it carefully, and your time starts now. Let's reveal those answers and see how you did. So mark your own answers off against these and figure out how many that you got correct. We'll whiz through them now. So A was matched with 4 because a schema is literally a cognitive framework. You may come across lots of definitions about that, but this is one that will help you all the way through your course. So cognitive framework that helps us organise and interpret information. B, capacity. This is really important for memory. You've got to remember, especially for B, C and D, the difference between each of them. This is where students can sometimes make some mistakes that will be costly. So capacity refers to storage space. C, duration, refers to, it's a time-based terminology, so it refers to how long information can be stored for. And decoding is about how it's processed. So you'll come across things like visual processing, semantic processing, and so on. And that's what we mean by coding. If you're using some older textbooks, you might see it called encoding instead. But let's use the correct term here, coding. And inference, again, another term you'll use quite a bit for the cognitive model, is an assumption or a conclusion, and you do have to use either one of those words when you describe what an inference is, based on interpretations of something. So we see that come up quite a bit when we talk about how unreliable or how invalid research from cognitive approach might be. Well done. If you've got at least some of them correct, that's a good start. So let me just go over the cognitive approach and memory and just give you a bit of an idea about why we're having this session. So memory itself features in the cognitive approach. It's a massive approach, but this is one dedicated area that you've got to know. And memory is a cognitive skill. So anything that we use the mind for is a cognitive skill or function. Things like language, perception, problem solving, but memory is one of the ones that you've got to focus on for now. And memory is an example of an internal mental process, and by that we mean it's just something that we know happens in the mind, and that causes us a problem because it's internal. It means that we can't actually see it. We can't see memory working. We can't see what a memory structure looks like, and that goes back to the term inference, and that's why we have to draw inferences. We have to rely on conclusions made about memory, and that's where we get into some sticky problems with the quality of research. The cognitive approach also think the brain is like a computer, so you'll come across the computer model. In that sense, they just think that the brain is very much like the central processing unit of a computer. It's the main thing that keeps everything ticking over and working together. And then other parts of the brain or other parts of the body might be similar to other parts of a computer. The basic example there is your eyes as the monitoring system. We've got memory or storage, similar to the RAM that you might find in a computer. So that's just one proposal. It's not the only thing that they say, but it is something to consider going forward. Now, there's a couple of sections on memory on your specification. 1. The multi-store model of memory. Hopefully you'll recognise this diagram from Tutor to You. So this just tells us how memory might be built according to the multi-store model. Now, when you go through this, make sure that you focus on the characteristics of memory. So everything you see in the blue box there, sensory register, short-term memory, long-term memory, they're all memory stores, but each of them has got different capacity, different duration, and different coding. So I'll give you one example. In the short-term memory, we get information there by processing it mostly by what it sounds like. And we know that because people make mistakes when they're trying to process acoustically similar items. And if they weren't trying to process it acoustically, we just wouldn't make them mistakes. Whereas coding in the long-term memory is mostly done by semantics, meaning it's based on something personal, what it means to you, the deeper understanding of something. So I've mentioned 2 types of coding there, but it is important to note that actually we're all individual. We're all different, aren't we? We've all got our skills. So some people may process things visually, and that's absolutely fine. Other things that you have to know on this topic for memory are recognition and recall. So make sure that you can focus on what those two mean. And I think that's really hard because they in our normal everyday language, they're quite similar, aren't they, those terms? So make sure that you've got a clear, distinct definition of each, because you could get asked a question on what is recognition, and you could get asked a question on what do we mean by recall. They could appear on the same paper, which tells you straight away that the exam board are expecting a different answer. So make sure that you've got a clear distinction between those. You'll also come across retrieval cues. So this is where we'll use cues in our environment or even our emotion to try and help us remember better. You may have thought, why do we have to take our exams in an exam hall? Why can't we do them in the class where we're familiar? Well, the idea of exams is to strip you from retrieval cues, get rid of that familiarity, get rid of all the stuff that's been around you when you've learned the content of your topics, and take you to an unfamiliar place. So retrieval cues, you'll probably recognise a lot of that in your own types of learning and exam practice. And another one, reconstructive memory. Now, I've put an image here of a broken tape because actually what a lot of people think in this approach is that memory is like a tape, that we can rewind our memory. We can rewind and we can see things as clearly as we can when we first learnt them. But actually, a lot of critics think, no, we can't. We're a bit more complex than that. We're not a videotape. Once we start learning other things and we have other emotions and we have other conversations, anything that we remember will become distorted. And reconstructive memory is going to focus on why that is the case. So, good distinction there between the topics in this area. Let's have a little bubble quiz. So you can have your pen and paper ready. The number of answers that are correct can range from 0 to all 4, but I want you to identify which are the correct answers to the question that will come on the screen. But you can also focus on how many of them are correct. Now, bear in mind, it might be none, could be tricking you, or it could be all of them. So, first one. Which of the following refer to memory capacity? So identify the correct answers. Do you think it's 7 plus or minus 2? Does that sound familiar? Space, processing, time. Or am I trying to trip you up? Is there none? The correct answer for this is there's 2 correct answers. So remember I said before, capacity is about storage space, so definitely B. And generally the belief or the assumption is from the cognitive approach that our short-term memory capacity is between 7 plus or 2 items. So in other words, between 5 and 9 things. We can store between 5 and 9 things before we start running into some problems. Processing and time, well, they're about some other different terms. Let's try that again. Which of the following are associated with reconstructive memory? Confabulation of information, dishonesty, accurate recall, shortening of answers. What do you think? You can have a guess at how many you think are correct, or you may be able to spot which are the actual correct ones, and even further, justify why they're correct. Here's our answers. So the correct answers are A, confabulation of information, which just means that when we try and remember things, when we try and reconstruct memory of an event, let's just say, imagine we're an eyewitness to an incident, To make it make sense to us, we can fabulate information. We might add in bits that didn't happen, not out of a maliciousness, just because that's the way our memory can play tricks on us. And D, shortening answers, we make it make sense to us. And if that means shortening answers and editing bits out, that's just what the memory does. And that's why we've got this big discussion about whether memory is accurate or not. Let's try it again. Which of the following are examples of how information can be coded? So we've got sound, meaning, humour, and vision. Hopefully this is nice and straightforward. If not, you might think about going back to your notes and going over this. Correct answers are sound, meaning, and vision. Now, humour might sound like it should be right, but actually, you're right, we do remember things that are funny. We might remember a joke someone's told us. We might remember a funny story in detail. But actually, the humour is what makes it semantic, what gives it meaning. So that's why humour isn't correct. And one more. Which of the following is a store in the multi-store model? So we had that diagram up before, but can you remember which of the following were on there? And I'm going to give you the answer. Only one this time, sensory register. The others are relevant for memory, but not for the multi-store model of memory. They're all to do with levels of processing or working memory model. Let's make this a bit hard then. So on the screen, I'm going to show you some summaries of research. Now, this is where we can start thinking about content that you could use for your AO3, for your evaluation. But I want you to think about how you'd use them. So would you use this to support a particular memory theory, or would you use it to challenge? And if you can, say why as well. If you need more time, you can pause the video, put your answers on your paper, and then I can give you some help afterwards. So here's our first one. The multi-store model of memory claims the capacity of short-term memory is 7 plus or minus 2 items. Cowan, 2001, suggests that capacity is 4 items of storage, which means that research is inconsistent and an agreement on the true capacity of short-term memory is yet to be determined. Bit waffly, but this is what you've got to do. You've got to be able to present arguments. So that can clearly be used to support or challenge the multi-store model of memory, but which is it? Pause it if you need a little longer, but the correct answer here would be B. Because actually, even though the multi-store model is saying, oh, capacity is definitely 7 plus or minus 2, we've got research that says it's so, we've now got another suggestion based on evidence from Cowan in 2001, which is telling us that actually it might be a bit less. They've got capacity down to 4 items of storage. So the fact, I mean, it doesn't matter who's right and who's wrong, but the fact that everyone is not in agreement with each other tells us that we've got a research inconsistency issue. And we can use that to challenge the multi-store model. So well done if you were thinking along the same lines. Here's another one. Abernathy, 1940, found that test results were better for students who took a test in the same room that they learnt the information in, rather than in a different room. And this explains why you may achieve better results in in-class assessments rather than tests in the exam hall. So where would we put that? Would you use that to support retrieval cues, or would you use it to challenge them? You can pause the video if you want a little bit more time or if you want to chat about it with somebody else. But the answer is here, A. So we would support the idea of retrieval cues here, because actually this study is pretty much saying what I said earlier, that when you are in an unfamiliar place, your test results are likely to be affected because we've removed all those retrieval cues. Now, if we're better at doing something in the place that we learned it, where we've got all those retrieval cues, then that supports how important those cues are in our memory. So well done if you said A. Let's have a quick true or false check of your knowledge now. So on the screen, you've got some statements, and all I want you to do is very quickly think about whether you think they're true or false. Of course, it's 50-50. You can guess if you like, but if you're not sure, you've got the option to pause, go to your notes and have a look and see what you think. So here's our first one. The serial position effect refers to our tendency to remember the beginning or end of things more accurately and easily than what's in between. True or false? Well, the correct answer here is true. This is exactly what the serial position effect is. Where would you talk about this when you are challenging the multi-store model? So they're telling us that actually we've got short-term memory, we've got a long-term memory, but what we can use this for is that actually there's an in-between there somewhere, and it seems that that in-between is important. Number 2, recognition is another form of memory retrieval in which a person identifies an object, idea, or situation as one he or she has or has not experienced before. So read that again if you thought that was a bit wordy. Some of these definitions can be tricky at applied psychology. And the answer to this one is true. So if you do need a definition of recognition, especially to make it different to recall, then make sure you get this down. Reconstructive memory is both something that can aid recall, but it can also be a problem. What do you think for this one? Remember that tape that I said before? This answer is true. So reconstructive memory can aid recall. There's a lot of things. Anxiety when you're witness to an incident can actually help, but it can also be a problem. And in the same way, reconstructive memory can help us make shortcuts about decisions. But when we start making shortcuts that mean that we confabulate, or we shorten things, or we edit, or we change the language because it makes sense to us, then that's when it can become a problem. So well done if you said true. Confabulation is when your memory has gaps from the original event, so you remove details to make it more meaningful and memorable. Read that carefully. This is a tricky one. And here's the answer. And it's false. Now, confabulation is something we've mentioned today. Confabulation is a problem with retrieval. However, confabulation is when we add bits. We add bits to the story. So this definition would be wrong because it's focused on removing details. The correct one here may have been shortening. We shorten an event by removing details. So unlucky if you got mixed up with that one. Okay, next task then. Can you work out what's hidden behind the question mark before all of the clues are revealed? So I'll show you on screen. I'm going to release some clues one at a time, and let's see how quickly you can guess what it is I'm talking about. The quicker the better, but obviously everyone's winner, so it doesn't matter if you need all 5 clues. So let's give you your first one. So the aim of this study was to investigate how memory of a story is affected by previous knowledge. Can you guess what study I'm talking about? Now, you may be thinking, we don't have to actually know all these studies. You're right, you don't. The specification's recently been changed. But it's good practice to know research, not only for your research methods and issues and debates and discussion, etc., but you're going to have to use research to support or challenge theories as well. So which one am I talking here? Here's another clue. The study looked at how schemas can affect memory. Can you think of a study about schemas? The strange story was used as a stimulus. Now that might be the giveaway. Participants shortened the story. That was the result because it was a strange story. And participants also edited the story to make it easier to recall. If you haven't got it, the study that I'm talking about is the very famous War of the Ghosts study by Bartlett. Well done if you got that one. Let's have another go. Here, coding is mostly done semantically, so we're looking for a place. Where is coding done semantically? Forgetting can occur through retrieval failure in this place. So where is it I'm talking about? What location? The capacity of this place is unlimited. The duration of this place is infinite, potentially forever. And last clue, to get your information may need rehearsing. Now, if you put all this together, and your memory might be jogged by that picture that we had up at the very start of the multi-store model. And of course, all these cues relate to long-term memory. Well done if you got that one. So it focuses on internal mental processes. So what is the it? What is the it that I'm talking about? It relies on inferences. Memory is just one example. Experiments are used to investigate it. Hopefully this is ringing a bell now. And your last clue, it makes assumptions, it assumes human minds are like a computer. Hopefully you've recognised straight away that that is the cognitive approach, which is, of course, what we've focused on in this session. So just to finish off, let me give you some final tips. So like I said before, you don't need to know all of the studies, but we would recommend knowing some because not only do they make it easier to understand the theory, but you can still use them and reach higher levels in your marks for evaluation. And they're also a really good way of understanding research methods. If you don't talk about studies, then you'll struggle to understand things like reliability, validity, bias, lots and lots of issues that actually we do need some research for a little bit of context. So well done, everybody. If you did struggle with any of those, you can obviously just go back to it and have another look. You can go back to this session and do it again and assess yourself.